Is Revit telling you the truth, or is it a blatant liar? Perhaps you've never actually tested this, but today I'm going to see whether Revit is accurate where geometry calculations is concerned. And for that, I'm going to get help from my dear friend Dynamo. I'm Luisa Santamaria, and I'm an architect and build consultant. Welcome to this Dynamo course. So I'm going to go straight to the meat. Right now, here I have a roof, a Revit roof, and another one right here. And right here, in the left side, I can see the area. And what Revit tells me is that I have right now 158.621 square meters. And I want to check up whether this area refers to the surface, the projected surface, or the real one. Okay? So I'm going to do that with Dynamo, and as I go along, I'm going to be explaining some fundamentals of Dynamo geometry. First step will be to open Dynamo. I have it right here. Second step will be, first, I'm going to get the area directly as Dynamo will get it, just to check up whether Dynamo agrees with Revit here. So first selecting the roof with select model element. Right here, and then asking him, okay, what's the area of this roof? Get parameter value. By the time you finish watching this Dynamo course, I hope you have this get parameter value by name tattooed somewhere right here on your left arm. I really hope so, because this one is really important. Let's get on with it. Okay, so right here I can see that it's exactly the same as Revit told us, but I still don't know whether this area is projected surface or is it the real area. So how am I going to check this up? First step would be to get the geometry. In order to get a geometry from a Revit element, I have to go for element.geometry, and like this I can get the actual geometry of the roof. Where is it? Right here. Okay, so I have what Dynamo will consider the roof's geometry. After that, I can ask this solid, okay, what's your area? Interestingly enough, I have here something very, very different from what I'm getting on the upper side. Here I had 158.62 square meters, and right here I have, it doesn't even match the units, okay? It's like 1 million something, 3 millions, whatever. So I'm going to try to see what units do we have here. For area we have square meters. For distance we have feet. I'm going to change it to meters. Length, I'm going to change it to meters as well. Remember that Dynamo is getting the units in what your project is using. So right here I have my units a bit different between them, and I'm going to just check out whether this changes the story, and it does not. Okay, so I will have to multiply by this. Still super big. This is quite strange. I'm going to close it and open it again, just in case the units are changing. Oh, this is interesting. As I changed the units while Dynamo was opened, this calculation did not change until I closed and opened Dynamo, because he was remembering the previous units. I think that's interesting if you are working with Dynamo and ever have this problem, to know how to solve this. This is obviously now in square meters as well as this, but as you can see, this is way higher than this one. Let's divide it between 2 and see whether I can offer you a valid explanation for this. And press run. If we divide it between 2, if we split it by 2, we have 174, which is quite similar to this one. Now, why may this be happening? It could be that even though this solid area corresponds to the truth, my God, the church bells. Thank you. Even though this area corresponds to the whole, how many times are they going to ring? Now, even though this area really corresponds to the solid area, ya terminó la iglesia. So, even though this area really may correspond to the solid area, it can be that the surface is calculated per 2. Because if you notice, right here we have a thickness. This roof has a thickness. So it may be calculating this area and the other right here, as well as these vertical surfaces, and summing it all up. This is why if we split between 2, this is quite similar, but we may have this to take into consideration. But as we want to really check out whether this area is truly the projected area or not, we are going to have to try a bit harder. We still don't know whether this area is the true one. So what can we do using Dynamo? We could calculate the projected area. Now, in order to calculate the projected area, what could we do? First, explode this geometry again. The solid geometry, gone. Okay, so let's explode this and see what we've got. I'm going to put this in automatic. 28 surfaces. Does this make sense? We have to count. Okay, how many panes did this roof have? 1, 2, 3, 4, 5, 6, 7, 8. 8 per 3, 24. Does this make any sense? Yes, it does. Because we have these 8 panes, 1, 2, 8, and we multiply them per 3 because right here we have this one, second surface, and third one. So perfect sense. Okay? Then after this, we will want to get the perimeter curves. Why? Because we want to project the perimeter. As you can see, we have this beautiful drawing. I recall going to architecture school and actually having to draw these lines in order to get a calculation or in order to get the shadow of them. I don't know if you remember this or if in your architecture university it was the same, but I would love for you to leave it down below in the comments if you had the same exercises as I did. So right here we have our roof with the perimeter curves of it, and what are we going to do in order to get the projected surface right here? Well, we need to pull these curves onto an horizontal plane. I'm actually going to draw a floor. Okay, level 0 sounds fantastic, great. So now I have this floor and I'm going to just select the face of the floor. Select face, right here, close it, we have this, under control, we have the surface, yeah. Yes, it is great. And now we want to pull our curves onto the surface, okay? Let's pull them. Let's just write pull onto surface. My curves, my surface, my problems start here. Okay, It says, cannot project input wire body onto sheet body. Why may that be? We have here 27, 126 and 126. Well, this may seem to have worked, even though it indicates it has some kind of problem. What I want to do next is to join these curves. Why? Because I want to get the calculation. Here. Right here I get 28 results, which is exactly the number of different surfaces I used to have. Now I have here a couple of nulls. Why is that? Because the vertical surfaces are projected as a line, so I can do a polycurve based on that. Next step, what could we do with these polycurves? We want to calculate the surface of these polycurves. However, we may not be able to get the surface of nulls. I'm going to try, okay, but we get some surfaces, yeah. And now we want to calculate the area. As you can see, in the ones that had null, we also had null as a result. So I'm going to calculate the area of these surfaces. Because of the nulls, we have already removed the vertical faces. And then I'm going to sum this and divide it between 2. It can't sum this nulls because we are using many nulls, so I'm going to just clean the list, remove the nulls. This isn't actually working. I want to take out the nulls, so what I'm going to do is ask this list, how many of these objects are nulls? In case they are null, I get a true, and I'm going to filter. So right now I have here on the upper side all the nulls, and on the lower side I've got the ones which are not null. If I sum it all and divide it between 2, I got 129.55, which is the projected surface. We have here the projected surface and we have here the real surface. This would be the real surface of all the roof. This would be the surface between 2, taking these vertical panes into consideration. So yeah, you can count down. Revit is not actually lying to you, nothing to worry about. The area is the real area of the roof. Thank you, Revit, for your consideration. Now, if you have come this far in the video, I want you to leave me a comment with an emoji of a house on it so that I can check out whom of you are really following along with this Dynamo course. Now let's get a summary of everything we've covered in this Dynamo. We didn't know whether the surface was accurate or not, whether Revit was lying or not. So first, what we did was calculate the area. In order to get an element geometry, we use this node element.geometry. In order to get the area, we are considering .area. Now realize that I have these different nodes, solid.area, and after that, surface.area. Exactly the same, it calculates the area, but take into account that where solids are concerned, normally they have more than one face. Also, we use this geometry explode, which I hope you found interesting, which decomposed the solid, the roof, which had 28 panes into each of their surfaces. Also, we use this one, perimeter curves, in order for us to get the perimeter of the different panes of the roof. After that, we use this polycurve by joint curves. This is used a lot. So first we get the panes, then we got the perimeter, and after that we calculated, we pulled them so that we projected them into this fantastic floor that we had right here. As you can see, we have the projection right here. It's not perfectly straight because the paints have an inclination. I did this on purpose so that this was not the perfect roof with straight, as you can see right here, with a straight line, but this has a slight inclination. This is why this happens, so as to get this projection. After that, after we had the projection and the polycurves, we did a surface by patch, and we calculated the area of these projected surfaces, removing the ones which were null. This is very important because when you are projecting, you will never get the vertical planes and filtering them, and this is just normal math operations, but I want you to remember from this unit the polycurves by unit curves, surface by patch, and the fact that you calculate the areas like that, and very important, this element dot geometry. So if you want to go ahead and watch the next video, I'm leaving it to you right here on this link. Come on, click it up, you want to click it. And also you can download our Dynamo guide and some of these examples down below. And you may subscribe to this channel. It's completely free. And this way you can keep following our Dynamo course. See you on the next video. Bye bye.